Good evening, everyone. So, here I'm going to discuss my custom solution for this leaf classification project. So, I have created my models, deployed everything. Now, if you want to see the work, say how much accurate, so I have deployed this on this link. I will share this link. You can go and look and actually experiment with this link. The model, the model works with both uh, on this web service on desktop as well as on mobile service. So it's a cross-platform solution. To use this, let us welcome. So this will from this will show this kind of now what you need to do, you need to go browse file. So what I will do, so what I have here in this project, so this is my original data set which contains classes of images, various classes of images. So during training, I have used the train set, right? This set, DNN data loader, there's another folder for this project. So train set is the set on which the model is trained. So we believe that the model have not seen yet these test set. So we will import some of them randomly and try to visualize what are the results from these. Let's first of all try to predict any random healthy image. So let's predict this image. So it will first try to download the model, load it, and then start predicting. So it is running right now for predictions. Let's wait for a while. Uh, I am using a free server for deployment purpose. I'm not using any AWS or GCP where we have access to cloud computing GPUs. So it is actually using CPU at the back end. That's why it is little slow. So given the resources at hand, this is the solution right now for like a temporary basis. If we like to deploy it, we can deploy it on embedded system like such as Raspberry Pi, ESP32 system based systems. We can also deploy these to cloud-based system like AWS, GCP, um, other web service like on random, such as in this case Heroku or other website development services. You can also actually deploy this model on a NVIDIA board that will be much faster because it has GPUs. So cloud compute, edge computing becomes very fast for inferences, right? And yes, now here you see the model has loaded the image. So this was the original image we have loaded. So the model gives us predicted class as healthy, right? And the confidence is 100%. It is confident that the predicted class is healthy itself, right? Now let's try to check it with some random image, not just from healthy class. Let's some wild class. Let's say some bad image, not that good quality image. Say this image. I will upload this image. It will try to again load the image at the back end, pre-process it accordingly. So here is our image that we have uploaded, random image, and so it is giving us a probability predicted class is viral. This image which you have inserted into the system, this web service, it is giving it is predicting that particular image as viral class with 99.98% is confidence accuracy. That is very good. That is actually very good. Now let's try to get some other class as well. This case a PML, some random image from PML. Let's take this random image from PML and it will do its pre-processing predictions and then give us the results. So here it is. So it belongs to PML class and confidence is 99.99%. That is a very good confidence score. Let's again try to. Now what I want to check, let's check it out on some random image. Not necessarily from belong to the test set, and just some random image. Uh, Let's try to visualize this on this box. Hmm. So this is a box. It is predicting it as SPW class, belongs to SPW class, but it is not. It is just a simple. So here the model is not giving good results because the model has not already seen this data. It is not trained on this kind of small boxes. Uh, let's again try to visualize this on some other classes, say this class. It has very small infection. Let's see, you can see that this is very small. So it is predicting it is bacterial. Nice, very nice, nice. Let's try to visualize this on some random images. Let's go to Google and try to find out some random images of lettuce leaf disease images. I want, say, I want to on this image. So what I will do, I will just save this image in my local device and download folder. Let's check it out. So it is classifying as healthy with 100%, but it is bacterial. Let's see some other, this image. Same in the download folder. It should not be healthy, right? Because it is has lot of contaminations onto it. Uploaded the new downloaded images. Uh, so it is again saying it is a healthy. So we can clearly see this deep neural network is little overfitting, right? We are getting this information. Let's browse and go to some other folder and go to SPW class, some random image of this SPW. SPW. Yes. So the model works fine on the dataset on which it is trained. So if you want to see more about this, learn more about it, so you can visit my GitHub. So I will include the GitHub link for you for your help. So here it is. So you can just clone this, and for the deployment part, if you want to see the deployed how I have deployed it, so you can go. This is my GitHub page. So this is the another one. This here I have trained my machine learning model in this repository. You can go to this repository and look for the methodology. It is completely modular and exploratory elaborated. So what in that particular repository, what you are going to find, you are going to find the data visualization, exploratory data analysis, and then I have experimented with various machine learning models, right? So you can go through them for your convenience. So here it is, everything. Apart from them, I have also utilized this DNN approach where I have custom made a TinyVGG model. So and also augmented the size, the number of images in the data set, such that we will find like the data set does not have class imbalance, such that it will learn only from one model while the less from other classes, right? So yes, we have done these kind of things. Everything is discussed thoroughly in this section. How you can import data, then create data loaders, unsqueeze them, how you can create your own custom models, and then train them. So everything is discussed in this chapter. So if you want to visualize the model performance and metrics, you can go down, and here I have trained it for some epochs. Here you can see these matrices, confusion matrices. Everything is discussed in detail here, right? Everything is discussed in detail here. You can go through this and visit everything. So I have utilized two DNN models for this, TinyVGG 0 and TinyVGG 1. So TinyVGG 0 performs better as compared to TinyVGG 1, as you can see from this classification matrix. So if you try to visualize all the combined plots here it looks like, right? So we can see that model 0 performs little better as compared to model 1, right? Everything is done here. So you can go through this. And for the deployment purpose, you can visit my this repository lattice leaf classifier deployment. I'm sorry, something else. So right now I'm using only this TinyVGG DNN model 0 for this web Streamlit deployment purpose, but there are a number of models. You can actually download them or even use MLflow run ID to actually then do experiment tracking with different models which you have already trained. So yes, everything is here. So these two repositories I will share with you. So you can go through it, the repository, and everything is discussed there. Thank you very much for your time. Thank you.